All right, and I want to lead you through an explanation of the geometric distribution. It's different than the binomial distribution in only one feature. The geometric distribution has built into it, into the question itself, the question of how many trials will it actually take. So we can go with the same example from the last segment of the video. Let's say that the probability of somebody speeding in their car going beyond the speed limit is 20%. A question might be, what is the probability that the first speeder will be in the 10th car? With a geometric distribution, the total number of trials is not known. In the question, each question will change, in terms of, what's the probability that the first speeder will be in the 10th car, will be in the 20th car, will be in the second car. And all that can be determined using, well, you don't necessarily need to use the calculator to do that. If we want the first speeder to be in the 10th car, what would we need? We would need 9 cars that were obeying the speed limit. So 0.8, 0.8, 0.8, 0.8, 9 times over. And then finally, on the 10th car, our first success. The same answer, which comes out to be about 0.03, about a 3% chance of that occurring. The same answer can be calculated using a shortcut on the graphing calculator, which is, again, found under the second and then the vars command on the calculator, bringing you to the distribution menu. And if you get to Geomet PDF, it'll give you the answer the same way. Unlike the binomial distribution, we don't know how many trials there's going to be in particular. We know the probability is 0.2, and we want our first success to be on the 10th car. So if you type that into the calculator, again, you'll get something very close to 0.03. There's also a Geomet CDF command, and that would be used if you were trying to figure out the answer to a question like this. What is the probability that it'll take fewer than 5 cars to get your first speeder? The way I wrote the question, probability that it takes fewer than 5 cars would mean that we want the first success to occur on the 4th time, the 3rd time, the 2nd time, or the 1st time. You again would type into the calculator to get this very quickly. You would type in, under the same menu on the calculator, Geomet CDF, the cumulative geometric command, and you would type in 0.2, which is the probability of success, and we want 4 or under for the number there. So if you used that, you end up getting about 59% chance. Now, in terms of actually graphing this, geometric distribution, the distribution would continue on and on forever to the right, because we have no idea how many trials will actually take in total. There's one more thing to teach you about the geometric distribution, and that's to be able to handle the expected mean and the standard deviation of a geometric setting. And these formulas are not given to you on the exam, but I've been told that students should be aware of what the formulas are. And the formula for the expected mean is 1 over p. That does make sense because in this particular situation, the probability is 0.2. You end up getting an answer of 5. So you would expect there to be an average of 5 cars that go by before you actually see your first car that's speeding, on average. that makes sense because 20% of the cars are speeding, which means 1 out of every 5. And by the 5th car, you would expect that to be, that you would have your first success by then. As far as the standard deviation goes, that formula is a little bit unusual. It's the square root of the probability of failure divided by the probability of success. So in this particular case, it would be the square root of 1 minus 0.2, which would be 0.8, divided by 0.2.
And that
ends up being 4.47 cars. Now, in terms of using the mean and the standard deviation together to explain the situation, you may use it in this kind of thinking that, most typically the first car that you'll see that's speeding is somewhere between this range right here. So a typical car, first car that you'd see speeding is somewhere between 0.53 cars to 9.47 cars, or you'd say between 1 and 9 cars would be the most likely first car that you'd actually see speeding out of a bunch of cars. Anything beyond 9, it'd be pretty surprising to see that would be the case, that would be your first car that was speeding. I hope this helped, and good luck to you, and more videos on the way. Remember, you can always request a video if you have any suggestions. Just all you gotta do is email me or post it on my YouTube channel.